Here we were given that a hero is fighting against a monster and has n skills. Ith skill is of type IA, and then he can perform all the n skills in any order. Means you can change the order according to you. Also, we were given that if the if the hero performs any other skill of different type after the current skill, then the damage can be doubled. Means if he performs a skill of 1 after 0, then also the damage is doubled. Or if he performs 0 after 1, then also the damage is doubled. So you have to find the maximum damage the hero can give it to the monster. So if we jump to the example, we get that he has 4 different skills, one of 0 type, another 3 of type 1. Now you have to arrange it to get the maximum skill. So we can arrange it in the order 101 for the maximum number of alternating pairs. Then also, even after that, you have to maximize the output. So for that thing, you can just consider this one to be the maximum of all of his skills of type 1. Here, 1000 is the maximum damage of type 1. So we can take this one to be of type 1000, as this is going to be multiplied with 2. And then the calculation is done according to this. The 2 is multiplied with this 1000, and the 2 is multiplied also with this 0 skill of type 0, because we have done a different skill after 1. After 1, we are doing 0. So the damage of 0 will be doubled. Also, the damage of this one will be doubled. For the explanation, we can go to our code. So yeah, basically, we take the input n, which is the size of the array, and then we are defining two vectors. For our convenience, we are defining two vectors, one of type 0, the other of type 1. Then we input this array of skills, of type of skills. This array is of type skills. We can just name it and then we'll input the array, the damage which hero can give. So that, or this is the skill of the hero. So we can name this as skill. While taking the input of skills, we are going to find the minimum skill. We'll use this afterwards. Also, you can just segregate the skills of type 1 and type 0 at the time of input. We'll push all the skills of type 0 in 0th vector and skills of type 1 in the type 1 vector and count their numbers respectively in Z and O. After that, we will sort these vectors. We sort the 0 vector and sort the 1 vector with greater precedence, means in descending order. Acha. Then we find the minimum out of the 0 and 1, which is the minimum number of 6. Yes. And then for finding the maximum output, we will just actually m alternating pairs will be generated. If you see here, the minimum is 1, means here the minimum number of different skill type is 1. We have 1 of 0 type and 3 of 1 type. So the minimum number is 1 here, and here 1 alternating pairs will be generated. So we will run a loop and find m number of minimum pairs. And we'll add it to the damage. I hope this part is clear, because see, we need maximum number of pairs. So the maximum will come if we take it from the sorted array, which is sorted in descending order. Here the 1000 will be the first element. As you get 1000 will be the first element, and then it will be 100 and 10. So first you will get 1000, then 100, and then 10. We will multiply it with 2 as it deals the double the damage of its own skill. After that, if the number of skills of type 0 is more than the number of skills of type 1, then we add the rest of the number of type 0 skills. If the 1 skills are more, then we'll add the left out 1 skills in the total damage. Now here comes the edge case. If both the number of skills of 1 and 0 are equal, in this case, we have 3 skills of type 1 and 3 skills of type 0. So you can see that each and every skills is multiplied with 2, except the first one. It's the smallest skill out of this whole lot, because see, we need the maximum damage. Only the first skill cannot be repeated. Means you cannot just multiply the first skill with 2, as it is the first one. So the minimum skill will not be multiplied by 2. The rest all will be multiplied with 2, and we get 63 as a damage. So as we found the minimum skill while the input, we can use it here, and we can just subtract this from the whole damage. As here we have taken 2, we have added it 2 times. So here we'll subtract it once. And yes, then we get our answer. This is the total maximum damage which the hero can give. So yes, this passes all the test cases. And I think the explanation will be clear.
सेकंड क्वेश्चन
एक बार हिंदी में बोल दूं क्या?
The second question was from prefix sum added, and here we are given that S of I. Here it is given the definition as S of I equal to the summation of first I terms of the array. We are not given the array. Actually, we are given S of I, but we are not given the array because we have to find the array. And for example, we are given S of I as a summation of A of k till I. Here we often use S of I as a prefix sum, and uh, and we are given the last S of items means we are given S of n minus k plus 1 till S of n. Last k terms of the prefix sum array is given to us, and we have to check whether the array is possible or not. But the constant here is given that the array should be sorted. If it is not sorted, then you have to print it no. Otherwise, you have to print yes. If you can form a sorted array using the criteria as given as the last k terms as S of n minus k plus 1 till S of n, then you have to print this. And input are like this. You are given t test cases and an integer n which suggests the length of the array you have to form, and the last k terms of the prefix sum array. And then you are given S of means last k terms of the prefix sum array you are given. And further, the condition is that the S of A lies from negative minus 10 to the 9 to plus 10 to the 9. So we have to consider the negative cases also. So here are the samples. For example, I have written. So you are given here n and k as 5 and 5. Means you are given the whole as k as you are given the whole prefix sum array. So here it is given that the first term is 1, and you can see that the first term is only the first term of the array, as prefix sum of s of 1 is what a of 1. So a of 1 equal to 1, means s of 1 equal to a of 1 equal to 1. And then but you have to get the second term you can get from s of 2 equal to a of 2 minus a of 1. This is an obvious formula because here you have given s of 2 as a of 1 plus a of 2. Then you can get the a of 2 as s of 2 minus a of 1. Okay. So 2 minus 1 as 1. Like this, you will get a of 3 as 1 and a of 4 as also 1 and a of 5 also equal to 1. So here all the terms are same equal to 1, and you are given the condition that a of 1 should be less than equal to a of 2 since equality condition holds. So it satisfies the criteria, and we can print yes here. And then we can see the second test case as -6. You are given last four terms of the prefix sum array. Okay. So here you can get the a of a of 5 as s of 5 minus s of 4. Okay. So s of 5 is -6 minus of minus 5 minus of -6, that plus 6 equal to 1, and then a of 6 as s of 6 minus s of 5. These are the obvious formula you can come across all this formula by intuition only. Equal to 2, and then a of 7 as 0 plus 3. Then here it comes as 3. Then our terms are what 1, 2, and 3. It means you are given a of 5 as 1, a of 6 as 2, and a of 7 as 3. But you have to check whether a of 1 terms, a of 2 terms, a of 2, a of 3, a of 4 are less than a of 5 or not. Okay. here from AF5 to AF7, you have got the increasing array, but you have to check whether you can come across this all these numbers so that the whole array can be an increasing array. So here we can do is part. Here we can do is we can make it as 0, then can make it as -1 equal to -1, and then we can make it as -4. Then here it comes as a of 5 as -6. Is it coming or not? -4, -1, -1. It's -6. Here 5 as -6. Yeah. Then we can get the array and it's sorted also. So we can print yes. But here it comes that here we are given n as 3 and k as 3. So we can again do this one. We have 1 equal to 3 minus 2 equal to 1. A of 2 equal to a of 3 equal to 2 minus 2. I have done a mistake. A of 3 it will be, and it will be a of 3. And a of 1 is given as 2. I have told in the first example only that the first term is the term if we are given k equal to. Then a of 1 equal to 2, a of 3 as a of 2 as 1, and a of 3 equal to 1. So it's not an increasing array, and we can't make it an increasing array also because first term is also only given as 2, and then it's decreasing the sum because 1 is coming and then 1 again 1. So we can't make it, and so the answer is no. And then the third test case is 3, we are given the array length of 3 and the k as the last two terms of the prefix sum array. Then we are given what is a of 2 equal to a of 2 is not, we can calculate a of 2, a of 3 we can get as 4 minus 3 equal to 1. Then, then a of 1, we have to assume something, and a of 2 also we have to assume. So here comes what we shall assume a of 1 and a of 2 so that the prefix sum a of 1 plus a of 2 is equal to 3. We can apply permutation and combination, but it will not come as increasing because first of all we can try as a of 1 equal to 1 and a of 2 equal to 2. It's it's not an increasing array because it's coming 1 cannot be come as 1. So it's not possible. Then again we can try as this test case is ruled out. So we can try as 2, then here 1. Since you can't make it as increasing array, and then we can do it as 1.5 and 1.5, which is again not possible as it's given in the question as it should be an integer. So it's also ruled out. So means you cannot make it as increasing array in any ways you try. So here the answer is no. So here you will get one logic that if we get the last k terms, then we can subtract the I plus 1th term and the ith term and get the last k terms of the array, and we can check for sorted. But the problem here lies is we have to check whether first term is possible or not. Here 3 is not possible because we cannot make it as make the sum as 3 so that the array can be an increasing array. So we can check here the condition so that we can check whether the first term is possible or not. Is that we can check if we can check is that we can check whether the term whether the term 3 is given as, then we can check as 3 minus 1 we will do into the number of terms minus k plus 1, whether it is greater than the prefix sum or not. Okay, so here is my code. And one you can see that if k equal to 1, if only one term is given, then it will be yes always. Here you can see also one more test case you can do. There are 3 and 1. If any term is given as 5, then it will be yes always, because it can be, the number can be anything, and and the answer will be yes always. So it will be yes if k equal to 1. But yes, if n equal to k means you are given the first term of the prefix sum array equal to the first term of the array. Okay, so you will form the array as you will push back the first term into the array, into the main array. Then you will push the other elements by subtracting, as I told, I plus 1th term minus ith term. Then here you have to, here these two lines are for checking whether the first term is possible or not. So here goes. If first term means the first term, you will take the first term of the prefix summary. Okay, that you will multiply with the number of elements left. Okay, number of elements not given. For example, we were given that 3 and 2. So number of terms not given at 1. Okay, I hope you will understand. 3 and 2, we are given number of terms n minus k 1 plus 1 we will do, so that we can check whether it is possible or not. Summation. Okay, here it is, and then we will multiply. If it is less than the first term, then we will directly print no. As if the summation is less than the first term, then it's not possible. Okay, hence we can do it, and then here it will return no, and then we will. This code is only for checking whether the array you have stored, whether the vector you have stored is sorted or not. If it is sorted, then it will come here and print yes. If it is not sorted, it will break and print no. I hope the solution is clear.